first one, again, if those numbers, 9 and 45, had a common base, we could do that without a calculator. So we can't do this one with like bases. Yes, 9 times 5 is 45, but that doesn't do us any good. Okay, that's not a base. 9 to the something or 5 to the something doesn't equal 45. So if we were doing this the way we've been doing it, we'd change that to a log and make that log base 9 of 45 equals x. And then we can use what we did yesterday in the calculator. We can say, now mine, if I hit alpha window, I don't have the most updated one like most of you do. So if you hit alpha window, remember it comes up with that little menu, and you can put the 9 and the 45 in. If you have an older calculator or not updated like this one, log of 45 divided by log of 9, and that gives you the answer. So that's one way to go about doing that problem. Again, most of you have an updated calculator where you can hit alpha F2 or alpha window. F2 is located at window. And then the screen comes up where you can put in the little base and the argument. Either way, you'll get the same answer. Another way you could do this problem is it's a calculator problem, so you could put this into y1, this into y2, and see where they intersect. So y equals, y1 is going to be 9 raised to the x, y2 is going to be 45. Now, before I graph that with a clear calculator, I would for sure know I need my y max to be higher, because I just put y equals 45. On my normal screen, it only goes to 10, so I'm going to make that 55. And then graph it before I start adjusting anything else. And there we can find the intersect. Second, trace 5, enter, enter, enter. And you get the exact same answer as we did doing it the other method. Either way works. We're not going to make you do it one way or the other on the calculator. Okay? Either way will get you that answer, 1.732. No work even has to be shown for that problem. Okay? If you want to do it this way and show some work, you can, but you do not have to show any work. Same thing with letter B. You could do y1, y2, and then go from there. Just remember the E button is right here above the natural log. So second natural log is how you would type in this. If we were doing, let's say this was on a non-calculator part, and we just said solve for x. That's also a possibility. Divide by 8. E to the 2x equals 5 over 2. Or you could simplify at the end. Then we would say the natural log of 5 over 2 equals 2x. Divide by 2, and there's our answer. There's where x equals. So you could type that into your calculator. Be sure that you close those parentheses after the 5 over 2, or you can change it to 2.5 before you divide it by 2. Or if you plugged them both into y1 and y2 and found the intersect, when you do that, you should get 0.458. Again, no work is required. You don't have to show all that work. I'm just telling you multiple ways that you can go about solving these in the calculator and showing you how it could be a non-calculator problem. This exact problem could say solve for x without a calculator, and this is where you'd stop. All right, here, 3 and 7. Again, this is a calculator because 3 and 7 have nothing in common, so I'd put this into y1, y2, and then see where they intersect, and you should get negative 0.229. If you're not getting those answers, when we're done, let me see what you're typing in so that I can try to help fix whatever mistake you are making. The next two, you can actually omit those. We're not going to worry about problems like that. If you want me to show you how to do them, I'm more than happy to do that, but we're going to omit them for now. And there's one on your homework, too, that we need to omit that's like that. Now, these are the problems that in Algebra 2, you had to take the log of both sides, then use the property, the law from yesterday that brings the exponent down in front, distribute, get the like terms, factor, divide, kind of like we did the inverse of the rationals in the last unit. But you have a calculator, so the best use of your time in y1 would be 8 raised to the 2x minus 1. Even though that says y, that's just the variable. That variable can be anything, a, b, c, d, e, anything. It just happens to be a y this time. That doesn't mean we're looking for the y value. Bless you. Here, 52 raised to the 4x plus 3. Be sure you type those in correctly. If your calculator doesn't give you the little exponent, be sure you put parentheses around it like I did. If not, it'll raise it to the 4x, and then it will add 3, which is a different problem. And then when you graph it, you're just finding the intersect of those two graphs. So once they both graph, don't get anxious. Let that little thing stop moving up there. If you have the other calculator, it's a little circular thing. Second trace 5, enter, enter, enter. And you get your answer. If you give me a coordinate point, that is not right. That means you don't know what you're doing. You're just typing things in and you're just guessing at what you need to do. Okay, we are looking for the x value. If you're going to use y1, y2 intersect method, you have to know what you're looking for. We're looking for the x value, so negative 1.196. So that's what I would expect on that problem. If you want to show more work than that, fine. But I would not expect any work on that. Same thing with letter G. y1, y2, find where they intersect, second trace 5, enter, 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 and you get 2.391. Rounding to the thousandth. That is 3 places, so the fourth number tells you whether you go up or stay the same. All right, so those are the calculator questions on that. Pretty easy, self-explanatory if you type them in correctly. You've got to type them in correctly, though. All right, so the rest of these are going to be non-calculator problems. So natural log of x equals 8. Dividing by natural log is not something we can do. The natural log is not like a 2. Okay, it's like a sine or a cosine. You can't divide by it. So we take the, if you like your little loop-de, you take the base to the 8 equals x. So e to the 8 equals x. We don't know what e to the 8 is. It's a non-calculator problem, so you're done. Stop right there. If that was a calculator problem, we would type in e raised to the 8th, press enter, and you get your answer. Letter B, we're solving. So we have to get this log 2x by itself. So we first subtract 4 and get 3 log of 2x equals 12. Then divide by 3. Log of 2x equals 4. So this is not log times 2 times x. It's log of 2x. The 2x is the argument. So at this point, now we have to do our loop-de. So 10 to the 4th equals 2x. Divide by 2. This is something we can go further. We don't stop right there. We have to know order of operations. We can't divide by 2 before we raise it to the 4th, so everyone can write 4 zeros after a 1 to get 10,000. Divided by 2, we can all do that also, so you get 5,000 as your answer. Order of operations, parentheses, exponents, then multiply and divide, then add and subtract. All right, so now we're kind of using some of those laws from yesterday, along with maybe your definitions. You could bring everything to the same side. I like to have logs on both sides. Once you have your logs on both sides, then you can just use this from yesterday. If we have logs on both sides and the arguments, we can set the arguments equal to each other. So that's what I'm going to use. So this is log base 4 of 5. We can combine those using that law from yesterday, log base 4, let's see, 10 over x. That would be the work I would expect to see. At minimum, that step of work right there. Some of you can look at that and know what x is. If you're still not sure, 5 equals 10 over x. Still not sure? Cross multiply, divide by 5, and you get x equals 2. Now, if you are one of those that tends to make careless errors and it can add up to 20 points on a test or quiz. I can't tell you how many times I've seen, up to here, I've seen 5x equals 10, and then you write 1/2. Not because you don't know what you're doing, you just get in a rush and you don't actually do this. I don't care if I don't have to see this. This is not work that I have to see right here. But if you tend to make careless mistakes, then you need to show each of those steps. That last test, I can't tell you how many people had the problem, I don't know what it was, the square root of x minus 1 equals y plus 2. They brought the 2 over and kept it plus 2. Instead of when you bring it over, it's minus 2. Those little bitty mistakes can add up. So just be careful when you're doing this easy math. Once we get here, it's easy math. If I gave you 5 equals 10 over x, that's one of the easiest problems you've seen. Now, getting to that point, you have to remember all your log laws. But at this point, be sure you show work if you need to do the easy stuff. All right, the next one is almost the same. Log base 3 of 8. This is x times log base 3. So those aren't the same. We can't divide by 2 or divide by anything like that. We want to get these to be the same. So log base 3 of 8, using our fourth law yesterday, becomes log base 3 of 2 to the x. We're using this law number 4 right here. It looked like this. We're moving it to this side. So now we have log base 3, so we can say 8 equals 2x. By now, we should know that 2 to the third is x very easily. Just like we know 2 squared is 4, we should know 2 to the third is 8. We've seen it so much. So this problem, when you first look at it, looks like it might be scary, but it is not at all. Just look at each side individually. So look at the left side, log base 6, log base 6. If we're subtracting, that becomes log base 6 of 3m plus 7 over m plus 4. If you know those laws and how to use them, the math is easy. Remembering the laws and knowing how to use them is the difficult part, just like the last unit. All the math was easy, but it was knowing how to use what formula to plug into what equation. Now this side, we can't really do anything with it yet. We have to first make this log base 6 of 6 squared minus log base 6 of 3 cubed. Now we can make that log of base 6 of 36 over 27. So that right side requires one more step right there, and some of you could come up with 36 over 27. I don't have to see both of these steps. One or the other would be fine. Now that we have two logs that are equal, we can set the arguments equal. So 3m plus 7 over m plus 4 equals 36 over 27. So a simple middle school math problem now, a proportion where you cross multiply. I would always try to simplify this if I can. Now, only if you can. Don't simplify things that don't simplify, that don't have common factors. We can divide both these by 9. And I personally would rather multiply by 4 and 3 than 36 and 27. Not everybody can do 36 times 4 is 27 times 7, 27 times 3 doesn't come quite as easily to you as just 4 and 3. So now when you cross multiply, be sure you distribute that 3 to both and get 9m plus 21 equals 4m plus 16. Goes to both of them, and then you just solve. Subtract 4, you get 5m. Subtract 21, you get negative 5. So m equals negative 1. Now, the thing about solving logs is you have to check. You can't just assume the answers all work. You have to remember that the argument and the base must be positive. So you have to look in the problem depending on what you're looking for. Where is the variable? The variable's in the argument. So if we plug in negative 1, this argument's still positive. Plug in negative 1, this argument is still positive. So negative 1 works. If that -1 had made any of the arguments negative, then it would be no solution. Okay, if it works everywhere, it's an answer. If it doesn't work everywhere, and it doesn't answer. If it works in one but not the other, it's still out, not a solution. All right, this one, letter F, is a little different than letter G. Okay, letter E. Letter E had logs in every single term. This one does not have logs in every single term, so we've got to work it a little bit differently. The left side, we're still going to combine the same and make log base 5 of y minus 12 times y plus 12, and that's equal to 2. Okay, that's all still the same. But now we can't set the arguments equal because there's not arguments on both sides. So now we're back to the way, like this is a problem that we would have done yesterday. 5 to the 2 equals the argument. 5 squared equals y squared minus 144. Y plus 12, y minus 12. The inside and the outside cancel because they're conjugates. Now you can either bring the 25 over and factor, or the 144 over and solve using square roots. I like square roots, and that's only because there's no y. A y squared and a constant, square roots. A y squared and a y, factor. So you get 169 equals y squared. Take the square root. When we take the square root, it's plus and minus. So y equals plus or minus 13. But before you box the answer, you have to check. Here we're looking for the argument. When we plug in 13, we get a positive argument. When we plug in negative 13, we don't. So we only have one answer of 13. Now, if you accidentally forgot to put plus or minus, then you accidentally get it right. Okay, but I would not count on accidentally. Okay, know that it's plus or minus and know that you check. Because the problem we did yesterday, both the positive and the negative worked. It was plus or minus 3, and when we plugged them both in to the argument, both of them made the argument still positive. All right, back to logs in all the terms. So this left side, log of x times x plus 3 equals log of 10. Now, log of 10 we know is 1. If we want to make that 1, we can. And then we'd say base to the 1 equals the argument. Or, since we have logs on both sides, we can just set the arguments equal. Either way, you're going to get the same answer. There are different ways to work it. Different way, same answer is fine. Different way, different answer, not an okay way to work it. Now, we can't do anything at this point. We have to factor. So subtract that 10 and get 0. You can use the quadratic formula. I personally would not ever use it if I don't have to. That's way too much work for a simple factoring problem like this. And we get x equals negative 5 and 2. But we have to check. Negative 5 makes the argument negative. 2 makes both arguments positive. So x equals 2. Negative 5 does not work. We only have one answer of x equals 2. They might both work, they might not. It just depends on the problem. So these last two problems are kind of more the pre-cal version of these. Everything up to now has really been Algebra 2 material. This is the one where when you look at it, you think, well, there's not like bases, so maybe it's a typo or it's a mistake or I can't do anything. That's not going to be the case. You're always going to be able to do something. So this left side is just like what we've been doing. Log base 2 of x times x minus 2, and then log base 3. If the logs aren't the same, we can't use this. We can only use log base bn equals log base bm if the bases are the same. So we can't use that. But what we can do is go back to the first day of logs and evaluate that. 3 to the what equals 27. By now, we've probably seen that enough to where we know 3 and 27 have something in common. If the base and the argument can be rewritten with the same base, that's equal to 3. So again, this problem by itself is just what we did in 11.3, that first day of logs. So now we can work this problem. 2 to the third equals x squared minus 2x. Bring that 8 over. X squared minus 2x minus 8. X, 4 and 2. We need a minus and a plus. So x equals 4 and negative 2. But check. 4 works. Negative 2 does not work. So 4 is our only solution. Negative 2 is just an extraneous solution. It's a solution, but in this particular problem, it does not work. It is an extra wrong answer. And this last one, the same thing. When you look at that, you think, okay, that's probably a typo, but it's not. We need to know that the natural log of e is 1. So this is log base 4 of 2x plus 1 over x minus 2 equals 1. Natural log of e is 1. So if you get something that looks like you can't do it, think about evaluating. What we did for 2 days, 11.3, 11.4. So then 4 to the 1 equals the argument. And now, again, it's a simple problem. You can multiply by x minus 2 on both sides, make it a proportion and cross multiply. 4x minus 8 equals 2x plus 1. Subtract 2 and get 2x. Add 8 and get 9. And then just make sure 9 over 2 works. The first one's positive, the second one, both arguments are still positive when you plug in 9 over 2. And so there's your answer. So today's lesson will not be on